A very good evening to all of you. I warmly welcome you all to the very first session of Step to IoT, a webinar series on Internet of Things organized by IET on campus, University of Peradeniya. To start today's session, if I ask the question, do you know anything about the Internet? I'm pretty sure that you will look at me in surprise and wonder whether I'm out of my mind to ask a question with such an obvious answer. Of course, almost all the people living in this 21st century know very well about the Internet. And in fact, it has become a part of our lives without which we cannot carry on our daily activities. Now, I'm going to switch the question and ask, do you know anything about the Internet of Things? I wonder how many of you would answer me with a yes. This webinar series is for all of you out there who are clueless or confused right now. We are going to cover many aspects of the Internet of Things throughout this series. And to start off, today we are going to talk about what the Internet of Things is, the differences between the Internet of Things and the Internet, as well as machine-to-machine devices. To conduct this series, we have two of the most renowned engineers from Sri Lanka Telecom PLC. I'm thrilled to introduce these two exceptionally talented products of the Faculty of Engineering of University of Peradeniya, Mr. Anuradha Udunuwara and Mr. Rajiv Weragama. Talking about engineer Anuradha Udunuwara, he is an expert in the field of telecommunication with more than 17 years of industry experience. He graduated from the Faculty of Engineering with a bachelor's degree in electrical and electronic engineering. He is the world's first MEF Network expert with many other related achievements. In his current role as the Senior Enterprise Solution Architect at SLT, he is responsible for consulting, advising, designing, and planning technical solutions for enterprise customers. Mr. Udunuwara is also a guest lecturer at our very own Department of Electrical and Electronics Engineering. Moving on to Engineer Rajiv Veradama, he is an expert in the telecommunication field with more than 12 years of industry experience. He has a bachelor's degree as well as master's degree in electrical and electronic engineering, and he's currently pursuing a PhD on Internet of Things at the University of Peradeniya. As a senior engineer at SLT, Mr. Weragama is responsible for service assurance and fulfillment of all SLT services in the central region in Sri Lanka. Both of these individuals are senior members of IEEE as well as IET. Apart from being engineers at SLT, Mr. Udunuwara and Mr. Weragama are researchers, trainers, as well as well-known speakers at Commonwealth telecommunication organizations. Now, to talk about all of their achievements, I don't think an hour would be enough. So I'm going to stop here, and without further ado, I cordially invite Mr. Udunuwara and Mr. Weragama to start today's session.
Hello, sorry about that. And it was Rajiv, and he has a small technical problem with his PC. And until he sorted it out, I think we should get started. And thanks for the nice introduction. I hope myself and also Rajiv are not strangers to you, though due to the circumstances because of the pandemic and all, that we are unable to meet physically, but thanks IET and IT on campus for organizing this type of events. So Rajiv is actually supposed to start with the first part, and I was actually planning to do the second half, but I think that it would still be okay, because Otherwise, we will be wasting time. I think we have about 68 participants joining online. Let me start with the second part. I'm sure that it won't make any difference, like you all being engineers and engineering undergraduates. Let me anyway go ahead and start this one. Okay, so can you see my slides?
Yes, sir, we can see them.
All right. So Rajiv basically wanted to start with the introduction to IoT and some things that were already communicated, and I saw that you guys have already communicated that via multiple social media tools as well. In my part of the session, I was actually looking at covering this short topic, right? It is short because I have used the acronyms. Otherwise, it is quite long. And I'm not going to introduce any of these acronyms, and I hope all of you know that. But as we move forward, I think you will get a better understanding of what each and every acronym actually mean, and also what are the differences between these acronyms and why it is important for us as engineering undergraduates to really understand the differences in these acronyms. So this is the first slide, which is about IoT and Internet. One of the things common to all these acronyms is that we really don't find any organization defining Internet of Things, for example, or defining what is Internet. All the definitions I show, for example, in this one, I think Rajiv has a better definition, but this is from Wikipedia, and what it says is something like this, as you can see on the slide. There is no one particular section claiming the ownership of IoT or IoT definition for that matter. And same goes for Internet, IoE, machine to machine, etc. But in the space of telecommunication and also in the space of ICTs, we have many organizations who are actually claiming the ownership, not really the ownership, but the definition, the ownership of the definition. For example, if you take SDN, it is defined by Open Networking Foundation, and we have NFV defined by ETSI, European Telecommunication Standards Institute. Now, IoT, as per Wikipedia, is like this. I'm not going to read it, but I hope we will be able to share the slides with you later on. The keywords highlighted, or rather shown in red color, is that the things in IoT are uniquely identifiable, right? So it's not, we are not just talking about that we have these things, right? But according to this description, although it is not really a definition, they are uniquely identifiable. And also interoperate within the existing internet infrastructure. Now, this is where we see the word internet coming in, or rather associating with the word things. And if you look at what is internet, we say in general terms, it is a network of network, or the largest network that we have. But in more general terms, internet is sort of interconnected between some computing devices, computers, servers, etc. And it runs on this protocol called Internet Protocol, and it basically links us, not necessarily devices, but links nowadays it links almost everything using this infrastructure. Now, although I said that we really do not have one particular organization claiming the definition ownership of IoT, we have International Telecommunication Standards or International Telecommunication Union, their standardization sector, which is ITUT. Within that, we have multiple recommendations. We generally refer them to as standards, but the real term they use, the ITU guys use, is the word recommendations. So basically, of course, it is related to telecommunication, but nowadays it is as the demarcation of the boundaries between telecommunication and IT and also ICT, as these demarcation and boundaries are getting blurred. ITU, of course, are having recommendations to things traditionally outside telecommunication space as well. So they basically categorize their recommendations under alphabetical order, A to Z. I don't think that we have the full 26 letters here, but things going with Y dot or standard Y is about the global information infrastructure, internet protocol aspects, next generation network, and also Internet of Things and smart cities. So not necessarily for IoT, but I would rather recommend that you at least go through these recommendations and see for yourself what are the things defined or described in each of these categories and what are relevant to your field of study. Based on that ITUT dot standard, this particular standard relevant to Internet of Things is Y2060, and it actually falls within this global information infrastructure and internet protocol type of classification standards. Within that, we see certain definitions, right? For example, that particular recommendation defines what's a device is, what's IoT is, what is a thing is. So although they do not claim these definitions are like ITU is defined by, IoT is defined by ITU, not like that, but these are some of the things that are coming from standard defining organizations. So we being engineers and you being engineers and engineering undergraduates, I think it's very important that we actually follow standards like this nature coming out of standard defining organization. For example, according to this 2060, a device is a piece of equipment, but the highlight here is that there are certain things with relevant to IoT. In the space of IoT, if you describe a device, that should have a mandatory capability of having the capability of communication. That device should be able to communicate, right? So that is the mandatory capability. Everything else, for example, in IoT, we talk about sensing, actuations, data capture, data storage, data processing, many things to do with the data that we really capture and to do with data analytics and data sciences, for example, they are actually defined as optional features. The mandatory feature is that device's ability to have some sort of communication. And also going with the same lines, IoT is defined as a global infrastructure for the information society. And also it includes physical and virtual things based on existing and evolving interoperable ICTs. And this is where, even though this does not include a word about internet, right? Of course, IoT stands for Internet of Things, but Internet as a network is not included in this 2060 standard. They don't really identify anything as Internet as a network. But the catch here is that if you look carefully, is that there's a word called global infrastructure. So if Internet of Things to be a global infrastructure, we know for sure that the only global infrastructure that we have today with relevant to ICT is the global internet, right? So that is where you can relate this Y2060 with all the general definitions or the descriptions of IoT, why an internet network or why internet is an important piece of Internet of Things. And of course, things with regard to IoT, they are the objects, physical or virtual, and also, as I told you earlier, they can be or they should be able to be identified, integrated, and also into a communication network, which is the internet. Now, with the same standard, if you look at what is the sort of rationale behind envisioning something like Internet of Things, why the industry or why the ecosystem came out with the concept of Internet of Things is about introducing a new dimension, if you want to take it that way, to the existing type of communications that we had before Internet of Things. Now we had, with all these communication technologies and communication infrastructure that we had this ability to have any place communication, like whether you are a human, whether it is a machine, whether you are at home, whether you are on the road, whether you are moving, whether you are at workplace or the university, irrespective of your place or irrespective of the place of the device, you can communicate. And the next dimension is actually the time aspect, right? Whether it is in the morning or in the night, on the move, irrespective of time, you or the device is able to communicate. Now, the third dimension with Internet of Things is actually more specifically classifying these things themselves, right? We generally say that things can communicate, and it says that Internet of Things, we give more weight to that, although things were there in the past which were able to communicate with themselves and also with the other systems and the human. So that is why we have this things type of communication is between computers, human to human, not using computers, human to things, things like that. So this is basically the introduction of the dimension, the new dimension of things with more weight, so that you can sort of think something like Internet of Things as a separate piece of study or separate area of research without generalizing things in the other common places. I hope you got what I really meant there. Now we have internet, and why it is internet? Why internet, or rather, internet is for whom or for what reason, right? So we can say internet for humans, right? We communicate using the internet. But with regard to Internet of Things, it is, if you really want to use the word for, it is internet for things, right? So if you generally take internet, it is in the context of Internet of Things, internet stands for internet for things. But what is different from internet and Internet of Things is that instead of for things, we actually have of things, right? So things are important here, right? So it's a network. Of course, it is a network, but we give more prominence to the end devices, which are the things, right? Not necessarily computers, right? But anything that you can think of, a thing is given more prominence in the word or the acronym Internet of Things. Internet of Everything, of course, it's not really a technical term, right? It is Some say it is actually a marketing term introduced by Cisco. I have seen it some places, but I really don't know whether it is something like that. But when you really read and sort of watch things related to Internet of Things and Internet of Everything, you really understand Internet of Everything is it's a more a general understanding. But it actually expands the concept of the Internet of Things to a much meaningful context. For example, it's not just things. We have people, we have data, we have processes. So it's basically Internet of objects, right? Objects include things, processes, data, people, everything. And the type of communication that we have is machine to machine, machine to people, people to people. But in Internet of Things, we are just talking about things. We really don't take the people factor, and we really don't take the processes factor, although we take the data factor because we collect data, process data, and analyze data. But normally people and processes factors, those factors are neglected in Internet of Things. The more prominence are given to is given to the things, and also maybe about the data that those things are associated. Now, so you can think IoE, or Internet of Everything, is basically an extension of what IoT defines. And also most of the so-called IoT applications are, if you really look at with the context of data analytics, they actually sort of IoE applications. And we have another term which is M2M, or machine to machine. And here the prominence is given to machines, right? A machine could be a thing, and thing could be a machine, depending on the context that you want to use the two words. And it's about more of a direct communication. We're not talking about a network as such for M2M. Even in literature, if you see, it says Internet of Things, which is internet. Since internet is a network, it's about something about a network. But even in literature, we see machine to machine, not machine to machine network, but machine to machine communication. So it's a more of a direct to direct communication from one device or one machine to another machine, right? So the only requirement is a communication channel, right? So it really does not mandate a requirement of having internet as such for machine to machine to be realized, or a machine to communicate with another machine. Although internet can be the infrastructure or be the platform for machine to machine as well, but it is not a mandatory requirement. And it is actually coming from this telemetry background, where we had machine to machine communication long before the invention of internet. Machines were made communicate with other machines in the past as well, basically to collect data, to probe, collect machine data for monitoring purposes, etc. So this is at very high level how one would want to classify and sort of segregate and sort of separate out the differences between Internet of Things, Internet of Everything, and machine to machine. As I said, the basic differentiator would be the ability, or rather in terms of communication, how it is done. In machine to machine, it is about communication, right? But we don't talk about a network. But machine to machine communication can happen on top of a network, for example, on top of internet. But internet as a network, or internet for things in the context of IoT, and Internet of Things, which is a network comprising of things, and also Internet of Everything. These are all about networks, right? So I hope you understand what is the difference between network and a communication and a communication channel. So to further understand, I have this one, I have put the source there. If you want, you can check later on. If you really sort of accept IoE as one of the uh, definitions or one of the descriptions of Internet of Everything. IoT actually is a subset of IoE. M2M is also a subset of IoT, right? So there are multiple differences and maybe some similarities. For example, point-to-point communication between devices, because it is the more focus is the communication machine to machine. But when it comes to IoT, it is IP networks exist between devices, integrating various protocols. It's about IP network. It's not about internet, right? So it's about IP networks. And then we have, with regard to the real requirement of internet, M2M can exist without internet. IoT too can work without internet, right? But in most of the cases today, IoT needs internet as a platform, the public internet, but it is not a mandatory requirement. I will show you why it is not a mandatory requirement in one of the next slides. And when it comes to IoE, it definitely requires active internet connection, because if you can see, the things associated with machine to machine is about just things, communication and applications, an application. And then with regard to IoT, we have something called storage, which means that we are collecting data. And when it comes to IoE, we are liberating it out, like more of a general description, where we have the people, things, data, and data processing, and also application. And integrating challenges are there in all these three categories, but in machine to machine, it is very minimal integration challenges, because these interfaces and communication are very well defined. But in the case of IoT, there are certain challenges, because now we are expanding it, not just one machine to another machine, but multiple things communicating over a network. When you're communicating from one location, one device, one thing with another thing, for example, machine to machine, it's point to point. So if you have the right interfacing and communication established, it will communicate. But IoT happens over a network. So, and it's not a homogeneous type of things. We are talking about vehicles, we are talking about refrigerators, we are talking about wristwatches, we are talking about air conditioners, light bulbs, etc., multiple different things. So the integration is challenging. It is more challenging in an environment of Internet of Everything, because we now have to do data analytics, processes, etc. So the main difference between machine to machine and Internet of Things and Internet of Everything is that with Internet of Things and Internet of Everything, our focus is actually, we have some more focus on data. Like in machine to machine, the focus on data collection, data processing is very minimal. But with regard to IoT and IoE, we have more focus on data and data processes. And this shows how Internet of Everything is sort of having feedback. If you take the people to the center, right? The people who are actually consuming and getting the benefit of all these technologies. For example, if you take people use things and things collect data, right? And the collected data can be processed inside that thing or the device, or it can be collected and passed on to another platform, maybe a cloud storage or a cloud platform to be processed. Basically, it can be processed in a computing environment. Once processed, it gives you some sort of intelligence, so that people can take certain decisions. So that is the cycle of sort of how people are connected to things, and things associated with data, and data, how data is processed, and what is the outcome, the again comes back to people. If you want, you can read this blog, which I did like almost 3 years ago for British Computer Society, looking at Internet of Things in a different angle. I actually wanted to call it network of things rather than calling it Internet of Things. So you are welcome to go and read if you need further deep analysis on that. What you have in that blog is something like this, right? So this is these are the things that you see, and I'm talking about a network there, right? Basically an IP network, because today things communicate using an IP address. So this is called a NOT, right? It is not, it is N simple OT, right? Network of things, right? So we really do not focus whether the network is internet or whether the network is something else, but generally we call this is a network of things. And if you really want to exclude internet, which we do in most of the Internet of Things applications these days, which we will discuss in the latter part of the series of these webinars. If you have a private network, for example, layer 2, layer 3 VPN network via intranet, right? Not internet, private network. This is a private network of things. Again, no association of internet. And the third thing, if the network becomes internet, right, then only that we have this notion of Internet of Things, which is in more academic perspective, I would like to call it as a public NOT, right? Public network of things, because internet is public. So that is all about the blog, but you can read it if you want. And these are some of the differences between machine to machine and IoT. I think I have already talked about many things, and for the interest of time, I think I should safely skip this slide because it is covered in the other parts. These two, right? This is machine to machine, point to point, but this is using a network. Usually we draw a networking schematic diagram as a cloud. This is not cloud computing, but this is a network. So you are connected to the network, and the network does the rest of the connection. You are not, of course, in terms of your traffic flow, you may be connected point to point, point to multi-point, or multi-point to multi-point, but it is basically you are connecting to a network, and the network is responsible of interconnecting the devices or the ones that are connected to the network. And also in terms of the type of protocols that we use, for example, if you take ISO SI stack or the TCP IP stack, going from the very bottom, I have, of course, this diagram, which the source is here. It has excluded the physical layer. You have link layer, layer 2 and layer 3, and then transport and application layer. It is more about the lower layers for machine to machine. If you look at the protocols that we use, for example, Bluetooth, we use Zigbee and power line communication. Using all these things, we can do machine to machine communication. But when it comes to Internet of Things, since it is about internet and internet is about internet protocol, you're talking about more of a application and upper layer, transport and application layer type of communication protocols. For example, we have certain Internet of Things devices which actually using HTTP protocol for communication, right, or something like that. And these are some of the examples of where we use machine-to-machine communication in day-to-day life, right from the very example of controlling a television using a remote control, or using your mobile device to control many things that you have at home, using things like these days, of course, Bluetooth, and if you support Zigbee type of communication protocol, you can use that as well. And this is another example. For example, in telemedicine, if you want to sort of read the heart rate or the pressure of a patient, and if you read it and get it to application where the doctor can actually visualize it, it's a point-to-point, machine-to-machine type of communication. Whereas if you want to automate, like having some interactive intelligence, you sort of give messages to a patient that you need to take a pill now. If he or she does not take that, you can alert one of his neighbors or parents or something like that. So it's many things associated. So it is kind of Internet of Things. And lastly, before I hand over to Rajiv, I want to show you this YouTube channel that I do with myself, Rajiv, and another one of our colleagues at SLT, Chamara. It is all about sharing knowledge, and you have several few videos about Internet of Things, both done by Rajiv, because he's the one who's having more expertise on Internet of Things. One on Internet of Things and one on smart, and we will be adding more videos as well. But if you really want to check something on telco softwareization, which is also related to Internet of Things, I'm doing a whole series of videos on telco softwareization. And also important, digital marketing. If you want to check that, Chamara is doing most of our digital marketing videos. So that is something extra for you to sort of continuously upgrade your knowledge. So that's it from my side. I think I have been fair on time. Rajiv, is it okay on your side?
Yeah, Anuradha, I can start. Let's see. I mean,
I'm sorry because since they were waiting, I wanted to go ahead and start.
Yeah, that's good. That's good.
I hope it is okay with the flow. So you can carry on, Rajiv.
I think all of you can see my screen, right?
Yes, sir, we can see.
Okay, thank you, Siri, and sorry for the interruption occurred. There was a sudden ghost effect, I would rather say, when I tried to switch on my camera. Anyway, for the time being, I'll switch it off, and once I complete the presentation, I'll switch it on. I think it's okay with you, right?
Yes, sir, carry on, sir.
Okay, so I think Anuradha has explained clearly what is the difference between Internet and IoT, and also the IoT and the M2M communication. I will start with the definition of IoT. There are so many definitions. If you search on the internet, you will find multiple definitions. And this is the latest definition published by the Oracle Computers, one of the premier industrial solution provider in the world. And they say that IoT is the network of physical objects full of things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. And IoT devices are pieces of hardware, and we could say that it consists of sensors, actuators, gadgets, appliances, and so many other machines that are programmed for certain applications and which are capable of transmitting data over the internet, or as Anuradha mentioned, over the other networks. So they can be embedded in mobile devices or any other industrial equipment, environmental sensors, and many of the other devices. And let's see what are the things which are mentioned in IoT. So it's not limited to the things which I'm going to show right now. First one is the computer devices. So it can be a desktop, a laptop, a tab, or even a notebook or something similar to a computer. And there can be communication devices spanning from pages, deployable mobile devices to satellites as well. And there can be machines which can be used for any purpose at the industry or any other place. And we usually find appliances at our homes, such as the lights, televisions, washing machines, toasters, and there are so many things which have these communication devices embedded within that device. And if you move on to the wildlife, we often see people fix some sort of tags on animals, either on their ears or around their necks, to track the movements of these animals. With these devices, animals also become so-called things. And prior to the era of IoT, these devices did not have any sort of capability of sending data back to the relevant authorities unless they capture that animal after a while. So with IoT, now they can track the real-time movements of these animals, and more importantly, they have some mechanisms to track these animals even without putting some sort of tag on their bodies. And if you look at the humans, now we have also started to wear certain devices and wearables. So we are also becoming a part of these things. And now most of the vehicles are equipped with such capabilities, and we will discuss more about the connected cars and self-driven cars in our future lessons. Apart from that, there are so many other devices which do not fall into these categories, but they fulfill the selection criteria of becoming an IoT device. So everyday people do so many researches and they think out of the box and they come up with new devices. So that may also fall into the category of IoT. And if you look at the impact of IoT by 2020, that is the last year, and about 2-3 years ago, it was predicted that by 2020, there will be more than half of the world's population will be connected with IoT devices, and that would create a huge revenue opportunity around $4 trillion. And there will be more than 25 million apps associated with the IoT devices. And there will be more than 25 billion embedded intelligent systems in the IoT domain. And ultimately, it will generate about 5 trillion gigabytes of data. That's a huge amount of data. And so far, in last few decades, we have experienced 3 waves in the development of internet. And the first wave occurred somewhere around 1993, as I remember. So that was the invention, that was the use of cable-bound internet, which was responsible for networking about 1 billion desktop users in early 90s. So the second wave happened in somewhere around the third quarter of 2003. And that was the advent of mobile internet, which connected about 2 billion users in late 2000. So initially it connected 0.5 billion, but later it moved on to 2 billion. And now we say that the IoT is the third wave in the development of internet. So in this network, it will connect billions of things in next few years. So about 125 to 150 years ago, let's say in 1875 to 1975, within the span of that 100 years, we have connected about 1 billion places. So in that era, our focus was merely on connecting places. So somewhere around 1975, we have connected, the total number of connected places reached the figure of 1 billion. And in 2000, we were talking about connecting people. As I remember, the motto of the Nokia was something similar to that, connecting people or something. So they were talking about connecting people. So within the span of 25 years, the telecommunication companies have connected about 5 billion people. And in next 20 years, now we are talking about connecting devices. So the number of devices which are being connected have been increased in an exponential manner. So you will see the depth and the challenges we would face in making those connections. Now let's look at the importance of IoT. So this figure will give you a glimpse of the importance of IoT. So IoT is being used in everywhere. So starting from the agriculture, it moves on to manufacturing, transportation, automobile industries, power or the energy, insurance, healthcare. Even we find multiple devices at our households, and it has an impact on the retail sector and even at the government side as well. There are so many other sectors, but I just mentioned few of them to give you a glimpse of the importance of IoT. And now let's see the factors that helped or accelerated the rise of IoT. The first one is the research. So with recent developments in nanotechnology has helped to reduce the size of IoT devices, and it has also improved the popularity of these devices among the people. And also with the improvements in battery life have helped the growth of IoT devices immensely. The next factor is the improvements in lightweight operating systems. So when the nodes become smaller, when IoT devices get smaller, there are certain limitations in their inbuilt capacities. So advances in lightweight operating systems have ensured that the users will get the proper use of the device at a lower cost, because we cannot increase the inbuilt capacities as we want. If we want to increase the processing power and the memory and other stuff, then we will have to spend more on these devices. So it will not become so attractive at the market. So if the operating system consumes less resources, that will be somewhat cheaper. And the third thing is the use of simple protocols. So under the constrained environments, if we have simple protocols which can do better, then that would be an added advantage. The next factor is the cloud computing. So before the invention of cloud computing, we had to store everything within that particular node. So cloud computing has got rid of the requirement of having local inbuilt storages. And compared to the mainframe computers we had in 1960s or 1970s, now we have multi-core processors which can perform millions or even billions of times faster than mainframes. And these are pretty much smaller in size compared to what we had about 50 years ago. And if you look back at the last 20 years or so, we have witnessed the emergence and development of wireless technologies in both short as well as long range in a considerable amount. I mean, we have seen the development of Wi-Fi, and there are so many short-range communication technologies such as NFC, Zigbee, and these have helped the rise of IoT immensely. And in an era where the data has become the new oil, because data is much more valuable than the crude oil at this particular moment, analytics play a crucial role in pattern recognition, predicting and forecasting the future trends, and making business decisions based on those analyses. Now let's see what are the main components of an IoT network. The first one is the sensor. So sensor is the layer which connects the IoT devices to the outer environment or to any other human being. As its name says, it senses the changes in the surrounding environment and sends data to maybe to the cloud for further processing. And we should have a gateway. That's the second component of an IoT network. So gateway facilitates the flow management and also the protocol layer to transfer data from one device to another. And it translates the network protocols for devices and supports to provide some sort of encryption for the data flow within that network. And we need to have some sort of components to provide communication and also the connectivity. So data collected by these sensors will be sent to the cloud for the analytics, and the mechanism, the communication mechanism we used in that particular network will provide the path to send those data to the cloud. And next element will be the cloud. So the IoT systems send massive amount of data from the attached devices, and this data needs to be managed in an effective and efficient manner to generate a meaningful output. So to store the huge amount of data, IoT networks more often use the cloud. And analytics is the process of converting the raw data stored in the cloud into some sort of meaningful form. So IoT analytics supports real-time analysis, which captures the changes happening around these nodes, and also it monitors the irregularities. And after that, the data is converted into a format which can be easily understood by the end user. Finally, we should have some sort of a user interface. That is the tangible part of the IoT network. So user interface should be user-friendly, and once the proper output is generated using the data stored in the cloud through the analytics, that will be sent to the user interface, and the end user can make decisions accordingly. So those are the main components of an IoT network. Now let's see what are the characteristics of IoT. So there are so many characteristics, but I have mentioned only 6 main characteristics. The first and the most important characteristic is the security. So safety and security are the most important features of any system. It doesn't matter whether it is an IoT network or any other financial service, the security is a must and the most important thing. If the system is not secure, then it will become vulnerable to the cyber attacks. So most of the IoT devices are dealing with personal data. So if the end users do not have any trust on the data they feed into the system, then they will refrain from using it in their lives. So privacy is a must. So ensure the privacy, you have to increase the security. And the next one is sensing. So sensor technologies provide us with the means of create the experience that reflects an awareness of changes in the physical world and people in it. The forms the input for the IoT system, and it provides a better understanding of the complex world around us. And the next thing is expressing. So that means interacting intelligently with the outer environment and humans. So expressing allows us to show output into the real world and input from people and the environment. The next characteristic is the connectivity, and it also one of the main characteristics of IoT, as it enables the system to send data and stay connected to the other devices. It provides system network accessibility and also help to function the total network in a collaborative manner. Now let's see what are the applications of Internet of Things. If you take the helicopter view of IoT, we can divide it into 2 main categories. The industrial IoT, we call it double IoT, and consumer IoT, we call it the CIoT. So Internet of Things is an umbrella term which covers both double IoT and CIoT. However, CIoT and double IoT also cover many use cases and applications, and thus they also becoming somewhat umbrella terms. And there can be overlaps between these 2 sectors or these 2 parts as well. There are certain applications which fall in double IoT as well as CIoT. We'll talk about more on these categories in our future lessons. Now let's see how we can categorize the IoT devices. Mainly, there are 3 categories. First one is the devices that can collect and send information. So they collect information and they do not respond to that particular information. Instead of that, they send that information to some other place. That's the first category. The second category is the devices that collect and respond to that information. So it has some kind of intelligence than the first category. The third device category can do both of the above scenarios. So it can either send the information to some other node, and also it can process it and respond to the that particular request. For an example, let's say we have a irrigation system and we have fixed some sort of sensors in the soil. So these sensors measure the moisture level in the soil. Whenever the moisture level reduces to some extent beyond some threshold, it can automatically water the crops. So if it is connected to the internet, the analytics can be used, and by looking at the weather forecast, it can reschedule the watering. For an example, let's say even though the moisture levels are lower and the weather forecast says there will be showers within next hour, then there's no point of watering the crops. It's a waste of water. And to do something like that, we should have a weather forecasting mechanism which we can rely on. I mean, if we rely on the data what we are available right now here in our country, then either the crops will die or we will waste more and more water. So the external factors we rely on should be somewhat trusted, and the data or the other things provided through that network should be highly robust. Now let's see what are the benefits of IoT. There are so many benefits of using Internet of Things in our day-to-day lives and industries. First one is the improved device communication. IoT encourages the communication between devices, also famously known as the M2M or the machine-to-machine communication. And because of this, the physical devices are able to stay connected, and hence the total transparency is available with lesser inefficiencies and also maintaining a higher quality. And it will also open up new business opportunities with new revenue streams. Business models are being changed frequently due to the new inventions, and because of that, new revenue streams have been generated. And automation and control is another benefit of IoT. And due to the physical objects getting connected and controlled digitally and centrally with wireless infrastructure, there is a large amount of automation and control in the workings. Without human intervention, the machines are able to communicate with each other, leading to a faster and timely output. And IoT helps us to utilize our assets in an efficient manner. So optimum utilization of energy and resources can be achieved by adapting the IoT technologies. So it will act as some kind of a surveillance system on this device. Possible bottlenecks, breakdowns, damages which may cause to the system, and at the end of the day, it will improve the productivity. And finally, all the applications of this technology will, can you hear me?
Yes, sir.
Oh, okay. And all the applications of this technology will culminate an increased comfort and convenience and better management, and thereby ultimately it will improve the quality of our lives. Now let's see what are the implementation challenges which we'll face when implementing an IoT network. Basically, we can divide into two categories. First one is the common challenges which will span across all the sectors and industries. The second one is the specific challenges. These challenges are specific for a certain sector or an industry. In this presentation, we are not going to touch upon these specific challenges, and in the future, we can discuss more on it. And now let's see what are the common challenges you would face when implementing IoT networks. First one is the difference between expectations and the reality. I mean, for a lot of industries, IoT is still in its early phase. It has not matured much. So there can be a gap between the expectations by the end users on IoT networks and what is feasible. So that bridging that gap would be a huge challenge. And the next one is the lack of properly defined use cases. So in a large number of cases, the scope and end expectation of use case is ill-defined, not well-defined, it's ill-defined. This leads to a failed use case without any business value while creating a doubt on return on investment, or in other words, the ROI. So because of that, investors will be reluctant to invest on a new IoT projects. The next one is enforcing security measures and data governance. So managing huge data and ensuring the privacy and proper security measures is a big challenge of incorporating IoT solutions. Suppose that, you're using a self-driven car, and due to a vulnerability in the security system, a hacker takes the full control of your car. So in these self-driven cars, you often don't find any kind of a steering wheel or brake pads or whatever. So if the hacker takes the full control of this car, then that means he takes the control over you as well. So you have to go within that car whenever he takes you. So the next challenge is the changed business models. Together, IoT and analytics based on connected devices are changing the business capabilities and also the delivery models. Finding resources with right skill sets and set the cost accordingly is a challenge for any business. And providing smart connectivity will be another challenge. So each and every device should be connected to the central node or to the cloud through some sort of connectivity, probably a wireless technology, and that differs from application to application. And next one is treating big data. So collecting a handful of data would be beneficial, but it would be a challengeable task when storing these data. Also, if we don't have the capability of analyzing it, then the total operation will be in a vain. Therefore, big data analytics will play an important and a crucial role in this context. And these networks are somewhat complex. So complexity is another challenge. So we need to find a solution to reduce the complex in these networks. The key is to find a scalable platform that integrates all aspects of the business to ensure seamless information flow across the enterprise. And finally, reducing the overall data latency, bandwidth, and power consumption will be a key challenge. So sensors will throw up a huge amount of data, and we have to maintain a sanity across all layers of the implementation. And also, we have to make sure that the batteries won't get drained out when trying to transmit a huge bunch of data. And there can be limitations in bandwidth, storage, and other things as well. So we have to manage all these factors. And there are some other applications which needs to send those data to the cloud and then for the analytics real time with a lower latency, or otherwise, if we do not process that data quickly, then we will not be able to use that data in any application. And out of these challenges, according to the Allocadia report published in 2017, it says that the security is the main concern in IoT. If someone breaches the security of one node, then that will have a bad impact on the other nodes as well. And the information or the operational tech integration and unclear return on investment comes thereafter. And it says now there are about 6 or 7 devices per person worldwide. So connecting such a huge number of devices require higher security levels to prevent scams and also to allow high level of data protection and integrity. That will give you an idea on the potential market, the size of the threat, and focus we should have on security aspects. So what would be the result? The increase in the devices per person will lead to the data multiplier effect. If you take the amount of data gathered at the level of business, and if you say it as 1, when it comes to the individual level, that will be 10 times more. And at the level of devices, that will be about 100 times of the amount we experienced at the business level. So that is known as the data multiplier effect. So we will talk more on these topics in our next few lessons, and we'll go deeper in coming weeks. So that's all from this session, and now it's open for the Q&A. I'll try to switch on my video. Let's see whether it will work or not.
So let's move on to the Q&A session now. Feel free to type in your questions in the Zoom chat. And I would like to mention that we have put up the link to the feedback form. Make sure to fill it today as well as in the coming weeks to receive the certificate of participation. And keep in mind that only those who fill the feedback form in all 5 sessions will receive the certificate of participation. And make sure to provide the name you want in your certificate in block letters, preferably your full name.
Any questions? So if you don't have questions at this point of time, or there's one question. When we prototyping a IoT project, we usually use ESP, sometimes PRIs, but now of these devices are not used in industry. What are the devices we can use instead of these devices for simple IoT project? I think Rajiv, you in a position to track that?
There are so many devices, and these devices differ from the use of that particular device. So based on the project, that can be, differ. So if you can send more information related to the project, what you are going to do, then we can support. In fact, there are so many processors and small devices. So please send us more information related to what sort of device or what sort of network you are going to make. Then we can send you more information related to that.
Any more questions? I think most of the participants are connected with myself and also Rajiv over, I think, on LinkedIn. And if not, I think we can type our email addresses. For example, mine is my last name at IEEE.org. You can drop me an email if you have anything to get clarified. I'll try my best to reply. Of course, we have a lot of things to cover as we move on. This is just day one. I think as we cover rest of the content, you will have more questions, more requirements of to get things clarified.
And also in your feedback form, please make sure to send us your views and what sort of areas you want us to cover in our next few lessons. So based on that, we can customize our lessons to match your requirement.
So Vimukti is asking, let's say smart power supply, for example, to an air conditioner that can turn on and off using mobile app. I think that is with regard to the previous question.
Yeah.
Rajiv.
I have to follow those data sheets. Vimukti, I mean, just send me your email. So I'll personally respond to you with some important data sheets. So we have some contacts in the industry as well. So I hope we will be able to find a better and a matching processor or chip or whatever you want in coming days. So just send me the email address, so I'll respond to you. Yeah.
So do you have any more questions?
Vanodya Varnasuryas, I have used Blink server, which is given free to some extent in IoT applications. What are the other servers? In fact, we haven't used any free servers. So in industry, in most of the cases, we are using enterprise solutions, not the free ones. So we'll check and let you know. Yeah, of course, you can build your own IoT platform. So you need those basic components, the sensors, the communication platform, some kind of solution to analyze the data, and also with the use of available infrastructure within the university and within the country, we can develop our own IoT solution. So you need some sort of out-of-the-box thinking to differentiate what you make from the others. So, I mean, it will be highly beneficial for not only to you, for the country as well.
And when you say an IoT platform, it is a very broad thing. Like, for example, when you say a platform, it includes for example, the application components and data components, and of course the communication network piece, and also the physical devices, sensors, actuators, etc. So, but I would rather recommend that you use most of the available things rather than trying to reinvent. Like for example, if you want to use IP-based internet-based, of course, internet will be your communication platform, or you can have any IP network. And if there are any standard protocols and platforms available, try to use them as much as possible, because that will make your total solution with less integration problems as we move forward, rather than trying to build it from the scratch. Like if you want to modularize it, try to use the modules available, and that will make the integration easy, isn't it, Rajiv?
Yeah, absolutely. I mean, it will take more time to build something like that from the scratch. So there are asset modules already built there, and Anuradha knows very well about the open source platforms. So those are there. So we can make use of it and start building our own thing from the place where the others have stopped. So that will not consume much of our time. So we can do something far more better than what others have done so far. So no need to start from the scratch. So we can use those things as well.
Looks like we have clarified all of our doubts now.
There's one more.
Oh, sorry.
Kiru is asking, could you share with me about most optimal network, which is low power energy of IoT infrastructure, and could you share about ThinkSpeak application? I think Rajiv will get back to him, right?
Yeah, I'll get back to him. I mean, has he shared his email?
Those who have asked questions, since you now have the email addresses of myself and Rajiv, if you want to post the question, please drop us an email, so we will get back to you.
So one thing, Kiru, I mean, Kirupaka, the low power networks will not always become the most optimal network. So it based on the application. So in there, I mean, there are certain scenarios. Let's say we are going to drop some IoT devices into a jungle. So in that case, these devices should have some kind of a inbuilt battery which will last long for a longer period of time. So, or in other words, they should have some recharging mechanism. But if you throw that, I mean, if you drop that device into the jungle, we cannot ensure that that rechargeable mechanism will work properly. So the optimal scenario would be some sort of inbuilt battery which lasts long for a while. And to preserve the battery, we can do the communication time to time. So it gathers data for a period of time and stores it within that node, then transmit it to the nearby devices or the central location. So in that case, that would be the optimal scenario or the optimal energy conserving scenario for that application. So that depends on application to application.
Let's wrap up the session for today now. Thank you, Mr. Weragama and Mr. Udunuwara, for spending your valuable time and sharing your insights with us. We are waiting eagerly for your participation in the next sessions as well. Thank you everyone for joining us and hope to see each and every one of you in the future sessions as well. Have a good night.